Something truly extraordinary is happening in astronomy right now. In the last month alone, the James Webb Space Telescope has captured galaxies engaged in a cosmic dance, detected organic molecules where they weren't expected, observed a planet with an atmosphere that defies all known rules, and unveiled galaxies so unusual that scientists still don't know how to classify them. At the same time, Webb is probing the early universe deeper than ever before, revealing massive galaxies formed too early and structures that challenge the foundations of modern cosmology. These discoveries go far beyond stunning images. They are forcing scientists to face uncomfortable questions. Are our models incomplete? Did galaxies, planets, and even chemistry emerge differently than we believed? Are we finally glimpsing hints that the universe's early chapters were far more complex than the accepted narrative for decades? Webb's most recent observations, from nearby galaxies to the limits of cosmic time, are reshaping our understanding of the universe step by step. The universe revealed by Webb does not behave as theories predict. According to the standard cosmological model, the universe arose about 13.8 billion years ago in a hot, dense state known as the Big Bang, and has been expanding ever since. As space expands, galaxies move away from each other. The more distant the galaxy, the faster it appears to recede. This phenomenon is measured by cosmological redshift. As light travels through expanding space, its wavelength stretches toward the red end of the spectrum. The greater the redshift, the more distant and older the observed object. Looking at distant galaxies is the closest we have to a time machine. For years, however, there was a clear limit to how far it was possible to see. The Hubble Space Telescope revolutionized astronomy, but was not designed to observe the deepest infrared. One of its most distant discoveries was the galaxy known as GNZ11, observed just 400 million years after the Big Bang. It was believed that galaxies beyond that point were extremely rare. This changed with the commissioning of the James Webb, specifically designed to detect the faint infrared light from the earliest cosmic eras. When it turned its gaze to the deep universe, the expected void simply did not exist. Instead, Webb found galaxies in abundance. Dozens of galaxies emerged with redshifts greater than 11. Some formed only 200 to 300 million years after the universe began. One of the oldest, known as Glass Z13, existed about 300 million years after the Big Bang. Even more surprising than its age was its quantity. These were not isolated anomalies but common objects. This created an immediate problem. According to current models, there wouldn't be enough time for galaxies to form, much less to grow and become bright. Yet, Webb observed them already mature. As the data were analyzed, galaxies emerged that were not only ancient but also massive, rivaling or surpassing the Milky Way in stellar content, despite having appeared less than 1 billion years after the Big Bang. According to the standard model, the dark matter halos needed to form such systems should not yet exist. Something didn't fit. While rewriting the history of the early universe, Webb also transformed our understanding of nearby galaxies. In a striking image, it captured 2 dwarf galaxies caught in a gravitational embrace, performing a slow, elegant cosmic dance. Although small compared to giants like the Milky Way, Webb revealed complex structures within them, bursts of star formation, and delicate streams of gas shaped by the interaction. This reinforces the idea that galaxies are not static islands, but evolve through encounters, collisions, and exchanges of matter, processes likely even more common in the young universe. Webb's impact also reached planetary science. In one particularly intriguing observation, it studied an exoplanet orbiting a pulsar, the dense remnant of an exploded star. What it found was disconcerting. An atmosphere dominated by unexpected molecules, with a composition unlike anything ever observed. This world challenges current models of planetary formation and survival. How can a planet exist around such an extreme object? And how did it acquire an atmosphere that seems to break all known rules? One of the strangest discoveries arose during the search for distant, faint sources. Astronomers using Webb's MIRI instrument detected an extremely red and faint object invisible to previous telescopes. It didn't move, it wasn't a nearby star, and it couldn't be easily explained by dust. Several hypotheses were considered, but none fit well. The most convincing explanation is that it is a new class of galaxies, compact, intensely luminous, and unlike anything known. Similar objects have already been nicknamed the platypuses of astronomy, because they don't fit into existing categories. If this interpretation is correct, its redshift could reach about 15, placing it only 100 million years after the Big Bang, which would make it the most distant and oldest galaxy ever observed. The implications are profound. These compact galaxies appear too large, too bright, and too evolved for their age. According to current cosmology, there simply wouldn't be enough time for them to form. Yet, Webb continues to find such objects, some containing more stars than the Milky Way, despite having emerged within the first billion years of the universe. This directly challenges the idea that dark matter halos are a slow, indispensable scaffold for galactic formation. Faced with this, astronomers are formulating questions unthinkable until recently. Did galaxies form faster than we supposed? Does dark matter behave differently in the early universe? Or is something fundamental missing from our models? For astronomer Claudia Lagos, the presence of such massive galaxies so early represents a serious challenge to the standard cosmological framework. To explain what Webb observes, scientists are exploring new ideas, from adjustments in star formation efficiency and exotic behaviors of dark matter to bolder concepts such as cyclic universes or the possibility of our universe having emerged from the remnants of a previous one. Nobel laureate physicist Roger Penrose, for example, proposes that the universe may be just one phase of an infinite cosmic cycle. As the mission of the James Webb Space Telescope advances, expectation grows. Every new image can confirm old theories or completely overthrow them. What is becoming increasingly clear is that the universe's first years were neither simple nor tranquil. They were dynamic, dense, chemically rich, and surprisingly productive. Galaxies formed faster, chemistry emerged earlier, and complexity appeared where it was least expected. Thanks to Webb, we are not just observing the universe, we are rewriting its history, and this journey is just beginning. Thank you for watching. While you're here, don't forget to like and subscribe to the channel. Click on one of the recommended videos on the screen for more incredible information. See you there.